As promised, we're going to talk about another networking model here in just a moment as soon as I remember how to use the mouse. And there we go. The TCP/IP networking model. Now, the model we're going to talk about in this session or this video uses layers to illustrate the data transport process, or the data chopping process, if you will, but only 5 layers in this model as opposed to the OSI model's 7. And for both your CCENT and CCNA exams, it's an excellent idea to know what the layers of each model are. Hey, perfect, makes sense, right? The responsibilities of each layer, you knew that was going to be on there, and how the layers of the two models map to each other, and that is coming up. Here is the latest version of the TCP/IP model, going from top to bottom: physical, data link, network, transport, application. So if we've got 5 layers here and we've got 7 layers in the OSI model, and they map to each other and they're really illustrating the same processes, there's got to be a layer here, at least one in the TCP/IP model, that will map to multiple layers of the OSI model, right? And here is that mapping, and you can see that this mapping is as straightforward as it could possibly get, and that is a pleasant change. More on that in a moment. You can see the bottom 4 layers of each model: physical, data link, network, and transport, map directly to their same name counterpart in the other model. That is easy exam points. Watch the top one, because in the TCP/IP model, you have the application layer, which maps to the session, presentation, and application layers in the OSI model. So everything that's done in those 3 layers that we talked about in the previous video, session, presentation, and application, it's all going to be done by the application layer in the TCP/IP model. Now, you TCP/IP model veterans, those of you who were around for previous versions of this, know that this is a lot easier to deal with than the previous model. And you'll notice that one of my layers there is bulging just a little bit because I wanted to put at least 2 of the 4 names that layer had. And I could have done the same for the bottom, because this was just a nightmare. Because the first and second layers, going from bottom to top, you'd see different names in different books and in different PDFs online and in different websites online. And I would get emails all the time, which is which? So this model is really gone. The main reason I'm mentioning it to you here in this course is that you may see it if you are using an older CCENT or CCNA book to study. Not a horrible idea, because 95 to 98% of the material discussed doesn't change, although the new CCENT and CCNA, the one you're studying for now, has more topics. But if you see documentation, or you're looking through an old book and you see the TCP/IP model and it looks something like this, or it's got some layer names that you're not familiar with, it is the old version. This is the version you should be familiar with. Again, physical, data link, network, transport, and application, going from bottom to top. So let's take a look at what we've got next. Like I mentioned here on the board, the internet layer is bulging a little bit because I wanted to put at least 2 of the known names. I mean, it really was pretty bad. I'm much happier with the new model. Now, as you've seen, there's really nothing tricky about these models, and they're going to be easy points for you on exam day. Having said that, when you're asked questions on exam day about these models, be sure you give the answer according to the model you're being asked about. If you're asked about the OSI model, don't give an answer that corresponds to the TCP/IP model. Now, it would be fairly easy for it to be the same layer, because, as you see, the bottom 4 layers of each are really the same. But just watch this application layer for the TCP/IP model and how it maps to the top 3 in the OSI model. It's a good thing to keep an eye on. Now, one more question that I know some of you are thinking about at least one point in this part of the course: why do we use these things anyway? And it's not really to aggravate you on exam day, although it may seem that way. Now, one technical reason is that networking models help software vendors create what we hope are interoperable products. And, that doesn't always happen, but it usually does. But that's not something that really impacts us immediately. Now, since we're the people who may be putting that software in, it impacts us then. But for our purposes, breaking the overall networking process into these smaller pieces makes it easier to learn networking in the first place. And I know I went over this earlier, but I just want to discuss it with you one more time because it works for Cisco, it works for anything. If you break a complex topic down into smaller pieces, then you just keep mastering one piece at a time, or in this case, one layer at a time, and you'll master it. Because I'll give you a hint about something. When you go after your CCNP eventually, which I certainly hope you'll do, there's something in there called the Border Gateway Protocol, BGP. And it is, to that point, unlike anything else you've seen in a routing protocol. The tables are different, the terminology is different, it has attributes that other protocols don't have. So it's kind of like you're going from one language directly to another. And it can really throw you at first. It can be a little confusing. And I'll get people who are studying for their CCNP route exam, which is a very challenging exam. I say, man, I've got this down, but this BGP is killing me. And I just tell them, hey, one attribute at a time, one part of it at a time, and soon it's all second nature to you. Now here's another reason why we use these models, and this is very appropriate for our real-world use. This helps you structure your troubleshooting approach. And when you think about it, a lot of things that we look at in this course, we're really building them from scratch. Now I'm going to show you some real-world scenarios throughout the labs where I'll say, hey, this is something I saw in the real world. What would you do? Here are the troubleshooting tools you have that you might want to use, that kind of thing. But you can have all the troubleshooting tools you want, but if you don't have a structured approach, they're not going to do you a lot of good. And really, most of what you and I as network admins do in most jobs is troubleshooting. It's not like we go in every day and start our switching networks from scratch. It's not like we go in every day and configure our routing protocols, again from scratch. They're already there, but problems do arise, and it can be as simple as a print job or maybe an enterprise-wide issue. I always tell students to start troubleshooting at the physical layer. And by the way, I tell non-students to start troubleshooting at the physical layer. I'm laughing about that because my wife works with a public school system here in Central Virginia. And she's now like the ad hoc tech support person. It's a position that I don't think she appreciates all the time. But of course, when teachers call in to her and saying, hey, something's not working with this, or I hooked this DVR up, it's not working, etc., she always tells them, start with the physical layer. And for those of you who are help desk associates, I have a baseball cap on right now, and I am tipping it to you because that is one of the most difficult jobs you'll ever have. It's a great job to have in networking because it teaches you to deal with people as well as the equipment and the hardware. And if you've never had a help desk job, I can tell you sometimes dealing with the people on the calls is more challenging than dealing with the hardware issues. And I always tell them, and I learned there, always start at the physical layer. You will be astonished to find out how many problems in the real world can be cured by finally getting someone to say, yes, this is turned on, where it wasn't turned on, or yes, it is cabled correctly. And there are really, in my experience, two kinds of network troubleshooters. And again, I've worked with tens of thousands of network admins around the world. And I can always tell the difference, ones who have a structured approach and the ones that don't. You don't want to be the one that sits down at the computer and just knows one thing to do. Well, I'll send some pings around, something like that, and then they really don't know what to do with the result. You've got to have that structured approach. And again, it comes down so often to, is this thing on? And is this thing cabled correctly? And we're going to look at all those cable types in a separate section of the course, and that's a big part of your troubleshooting toolkit as well. But you definitely want to be that number one guy. In short or in long, and I know I've gone on about this, but it is so vital for you on the exam. But I don't just want you to pass the exam. Obviously, we're going to get that done. But I want you to thrive out there in the real world. I want you to be ready for that. And when you have that structured approach, and when you're using these networking models as a troubleshooting approach, and you say, okay, I've gone through the physical layer, I know everything's fine there, let me go to layer 2. Then it's let me go to layer 3, and you just keep going up. That is a tremendous boon for your career, because when you're a real-world network troubleshooter, and the world is your oyster, you can do very, very well for yourself. And that is the end of this particular section. We're going to go ahead and head over to the second set of lectures now, and we'll do some labs in there hopefully as well. I will see you there.